ultra-high temperature applications up to 600 degrees Celsius. Welcome to this special webinar session recorded on June 10th, 2025. Our recently conducted webinar on pressure measurement in ultra-high temperature applications was a tremendous success, bringing together participants from across the country, including industry experts, professionals, freshers. In just one day, attendees gained clear, actionable insights into pressure sensing, exploring working principles, key features, and applications of Rocksensor's advanced transmitters, with a spotlight on high-temperature solutions. Now, let's dive into the webinar session.
Good evening, everyone. A warm welcome to today's webinar hosted by Rocksensor India. We'll be covering a topic that's pressure measurement in ultra high temperature applications. I am Anshika Arora and I'll be your host for the webinar. We feel excited to have participants joining us from across India. So let's welcome our speaker today. She's Ria Jangid. She's from the product team in Rocksensor. She's an expert and have experience in industrial instrumentations. So over to you, Ria.
Okay, good evening, everyone. Hope you have joined with a great pleasure here and would like to discuss each and everything with you in the session which we are going to organize today. So we are starting now. Hope my screen is visible to everyone. Okay, so today's topic is the pressure measurement solutions by Rocksensor up to 600 degrees Celsius. So we have the smart solutions also and the miniature version also for the industries where pressure measurement is required. So these are some solution here. You can see the images as well as this is our smart series and this is our miniature series. Now today what we are going to learn? We are going to learn the importance of pressure measurement and the types of pressure which we deal in, gauge, absolute, differential pressure. What is the technology Rocksensor is using currently, and what are the products we are offering? What will be the application in the industry? What we can suggest to our clients? What we can guide to our clients? So this is the learning today which you will have in this session. So first of all, we need to understand what is the importance of pressure measurement. See, in an industry, as the capital is very big, right? We are investing our efforts, time, money, each and everything in the industry. So we need a good quality product. Its output must be efficient. So that factors are based on some basic factors on which the industry runs, like pressure, flow level, temperature, the gases emission in the atmosphere. So why it is necessary? First of all, it assures the process control, right? It assures the safety in the industry. Second, we have the efficiency. We have the good product quality because as you see, it is a general example. If you are baking a cake at your home and if the temperature is high or the pressure is different, the cake must get burned or something happen and the taste will not be good. Similar happens in the industry. So it is very necessary to ensure the parameters which runs the industry. So equipment protection is there. Each and everything is based on the measurement, right? Now, what is pressure? We already have learned pressure, the force per unit area. Now, how we are going to use this in our transmitter? So the things are that the process, the things which we are using in this transmitter. we have different type of pressure measurement applications. The pressures are different. So first we learn that what are the types of pressure. So we have gauge, absolute and differential pressure. What is gauge? The gauge pressure is always measured with respect to atmospheric pressure. Now, as you all know, atmospheric pressure gets affected by the altitude. So, as I think, or that you all know, that the atmospheric pressure will be on a lower side or will be less on higher altitude and will be higher at low altitude. So gauge pressure is directly affected or measured with respect to atmospheric pressure. Now absolute pressure. So absolute pressure, the reference for this is the perfect vacuum. So we have perfect vacuum, which is minus 760 mmHg, right? Now what is absolute scale? The gauge pressure can be in negative and can be in positive. The maximum pressure goes in the negative is minus 1 bar, and the absolute scale will always be positive. It cannot be in a negative scale. Now, what is differential pressure? As the name suggests, differential pressure is the pressure between 2 points. One point will be at the higher side and one point will be at the lower side. So it will always measure the difference between two pressures. Now, what is the important thing here? The important thing is there minus 1 bar or minus 1 kg per centimeter square is never a perfect vacuum. A perfect vacuum is always minus 760 mmHg that we have to make understand to our clients, to our users, to the person to whom you are discussing or making him understand that this is the common thing for an absolute pressure transmit. Now moving ahead, what is the technology we are using? So the technology is based on the monocrystalline piezoresistive silicon sensor. So this is the transmitter. These are the parts of transmitter, and this is the monocrystalline silicon pressure sensor. Now, the piezoresistive sensor, why we are using piezoresistive sensor? So here the force, the pressure is exerted by the fluid on the diaphragm is directly converting into the output signal of 4 to 20 milliampere signal. Now, why we are using piezoresistive? Because piezo means pressure and resistive means resistive. So, through this thing, we can easily measure the output in 4 to 20 milliampere with the help of microprocessor because it is based on the electronics. Now, piezoresistive, it is based on Wheatstone bridge. As we all know that Wheatstone bridge contains four resistance in which one is unknown. So this unknown resistance is being known by the applied pressure by the fluid, and this will result in our output. Now, the series which we have, the smart series pressure transmitter, we have gauge pressure transmitter, absolute pressure transmitter, differential pressure transmitter. Now, what are the features we are offering? First of all, we have a high accuracy of 0.035% for these series. The temperature will be up to 120 degrees Celsius. We have ATEX, CE, SIL certifications, NAMO compliance. We have IP67 we are offering. It is with heart available, and it has reverse polarity surge protection and anti-lightning function is also available in this transmitter. It has push buttons on the top of the transmitter, and you can easily configure or change the setting through the push buttons. Now, what are the common uses across industries? So the transmitters can be used in liquid as well as gases, right? So some common liquids are water, solvents, slurries, acids, and some common industrial gases are nitrogen, hydrogen, oxygen, carbon dioxide, methane, and air, as compressed air also. Now, moving ahead with our remote seal type pressure transmitter. This is a direct mount type transmitter. So in this, as the previous transmitter's temperature range was up to 120 degrees Celsius, this offers a temperature up to 260 degrees Celsius. Many application requires high temperature for their process, and those processes cannot be measured directly with the help of the transmitter, which we have earlier discussed. Some applications can be done like steam. We can use impulse tubing, siphons, condensate pot to lower down the temperature, and we can directly use the smart type PT in that case. But some applications are there where acids are there, or the process only requires high temperature. We cannot directly use that. So here are the solution. These are the direct mount remote seal pressure transmitter. This can be directly mounted in the process. This is the diaphragm where the pressure will be exerted here, and the process is the same. The resistance, there will be change in resistance, and the output will be shown here in 4 to 20 milliampere on this display. Okay, so now what we can measure? We can measure gauge, absolute liquid level measurement. And what are the diaphragm? Now we can see that the diaphragm material can be different type depending upon the media for which it can be used. So it has SS316L, Hastelloy, tantalum with a coating of PFA, PTFE coating available. SS316L with gold plated, and we have flange from DN 2" to 4". It can also be customized in 1" or 1.5". Depending upon the application and the process parameters. Now moving ahead with the remote seal type pressure transmitter with capillary. In the previous, the transmitter will be directly mounted. There is no need of use of the mounting arrangement also. We can directly mount the flange in the process, and the diaphragm will go directly in contact with the media. Now, in this case, we need to use the mounting arrangement also because it is available with capillary. So flange will go inside the flange, and the diaphragm will go inside the process, and through the capillary we can mount the transmitter on a remote area, or at a distance of 1 meter, 2 meter, 3 meter, depending upon the capillary length which we are going to give to the client, or which our solution offers. So we can use directly these transmitter. The application is same where the temperature is high. We have to measure. Earlier one will be with 260 degrees Celsius. Now it is on the higher side. It is up to 350 degrees Celsius, and it can also be used from -100 to 100 degrees Celsius for our cryogenic applications. Okay. Now it is also available with different type of diaphragms with the SS316L, Hastelloy, tantalum with a coating of PFA, PTFE. Flange size can be customized or can be done changes, and it has a capillary up to 12 meters. Now, what is the use of capillary? Wherever the ambient temperature is exceeding with the transmitter's ambient temperature, we are using the capillary type transmitter, or the process temperature is high where the transmitter display cannot be installed directly. So the capillary is given. You can use the capillary as per your temperature range. For example, at a distance of 4 meter, the temperature range is within 80 degrees. So we can use and suggest the client to use a 4-meter capillary. So the display can be mounted after the 4 meter, and the process will get the diaphragm with the 4-meter capillary. So this is the capillary shown in the uh, transmitter here. So the capillary material is of SS304. It is the standard one, and application in the industry. So the application is similar to the previous one. It's just that depending upon the temperature, which process require what temperature, what is the maximum temperature of that process, we have to choose wisely the solution. So if in case the process temperature is 300 degrees Celsius, so we have to wisely choose our remote seal type pressure transmitter, and also make the client understand that this is the best solution for you and it is reliable, accurate for your process to provide you the accurate pressure readings. So some are the common applications are mentioned here. Molten sulfur, because sulfur temperature is already high. Sulfuric acid, brine water, and hydrogen gas, acidic water, sugar molasses. These are some common application across the industries. Now, the major application which we are going to discuss is the hydrogen. Now, as you all are aware that our government is empowering the hydrogen power. So it is the clean and green energy for the future. We are empowering our future. We are generating fuel through hydrogen. Now, how the pressure measurement is going to be done in case of hydrogen gas? See, the challenge in hydrogen is that if we are going to use the material directly with the hydrogen, for example, SS material with the hydrogen, it will cause hydrogen embrittlement. What is hydrogen embrittlement? See, the hydrogen molecules are very smaller in size. It will directly permeate the material surface and will make crack on it like this. So the hydrogen atoms can go easily inside the surface of the material. For example, if you are using this as a material of SS, so it can easily go inside it and it will crack the uh, diaphragm there and will cause leakage of the oil filling fluid inside the transmitter. Now, how we can achieve measurement for this case? So we have solution with the gold plating. Now we are using gold plating. How gold is used? So gold's molecular size is higher and bigger in size as with respect to hydrogen. And the coating here shown, it's of very micrometer, not a thick coating. A thin coating is required on this diaphragm. So how it is affecting or how it is improving our transmitter pressure measurement? So it acts as a barrier. It is a barrier layer and it will not even permeate a single atom of the hydrogen. It prevents the hydrogen absorption and also it is a corrosion resistance, right? So hydrogen system, as you all know, hydrogen system operates at a very high pressure. So that's why we use cold plating in this, because SS cannot be used at high pressure with hydrogen, or other material tantalum and H2C cannot also be used. Tantalum reacts with hydrogen and create tantalum hydrides. So that's the reason we cannot use. And H2O for a smaller or shorter span of time we can use, but it is also not suggested to use H2O. So the best solution is the gold plated transmitter, which can easily be used to measure the pressure in the application of hydrogen. So it is a great product. You can easily inform or tell your clients that we can use such innovative product because hydrogen is the future of the industry, and we can easily use this transmitter to uh, measure the pressure. Now we are moving ahead with our high temperature solution. So why we need to use high temperature solution? Why we are using high temperature pressure measurement? So we have so many limitations in the industry. So some limitations are the temperature. Some devices exist with a limitation of 400 or 450 degrees Celsius, and the maximum temperature is up to 450. Due to a wide exposure to the atmosphere or to the pressure, high temperature, the transmitter can uh, fail in that case, and there will be a shorter lifespan of the transmitter. So now this case will increase the damage of the process, which it will affect the damage of the process, right? In the previous slide which we were discussing for the hydrogen, I would like to add some points here. The minimum coating will be of 3 micrometers, and it can be customized up to 20 to 25 micrometer depending upon the exposure and how much the atmosphere will be. So this is the coating we provide in this. Now, moving ahead with the ultra high temperature pressure measurement. So now, what is the demand? So for the applications which cannot be measured directly, this is a good solution. We can easily get the accuracy, reliability, and for tougher application, we can easily provide the solution. Accurate monitoring is will be there, and it is the future innovation for the industry, because some applications which work on higher temperature up to 600 degrees Celsius. So there is a difficulty in measurement of the pressure. So this is a good solution for the industry. Now, what are the advantages? Some advantages are there. It is first advantage is that it is up to 600 degrees Celsius. We can use directly in the process up to 600 degrees Celsius. It is a direct measurement, and it is based on the dual isolation technology. We have patented solution, film fluid in this, which is of high temperature, and the accuracy is up to 0.06%, and it is safe and reliable for the application in which we are going to use. Now features are there. So its operating temperature is from 10 degree to 600 degrees Celsius. It can be used for gauge absolute and liquid level measurement. The diaphragm is SS316L #C 10, and flanges from 2 inch to 4 inch. Capillary we can offer up to 10 meters. Now, what is the technology behind this ultra high temperature pressure? So, first of all, it is a direct measurement for the high temperature solutions, right? So, it specialized heat resistant fluid. So, it is a patented technology, and the filling fluid is at a high temperature filling fluid. Now, double isolation system is there. So, the pressure from the high temperature measurement diaphragm is transferred through a special high temperature fluid to an isolation diaphragm. So from this, it will be passed on through this. Now from this isolating diaphragm, which contains the normal temperature silicon oil inside a capillary, is used to transmit the external pressure, this pressure, to the transmitter. So this is the double isolation technique, and in this no external cooling or heating is required. It is also available with anti-vacuum structure. So it is anti-vacuum to maintain the performance under low pressure and high temperature. So it is with anti-vacuum structure, and it is safe. It is available with safe and non-toxic filling like mercury and other. So the filling fluid is safe and reliable. It is not non-toxic. Let's get through some examples or application in this. So the application is the sulfur vapor at 600 degrees Celsius. So what happens? Sulfur. Okay, so one thing is that the temperature of this is from 10 to 600 degrees Celsius. This from 10 to 600 degrees Celsius. Okay, so some applications are there. So the first application is the sulfur vapor at 600 degrees Celsius. As we know, in the chemical industry, sulfur is required for so many applications like sulfonation or hydrogen sulfide and sulfuric acid, and in rubber manufacturing and other things. So the melting point of the sulfur is below 115 degrees Celsius, and the sulfur turns into vapor above 445 degrees Celsius, and it emits toxic SO2 if oxidized, because it's if it's combined with air, it always flames into a blue flame, and it reduces sulfur dioxide. So it has a very the viscosity behavior of the sulfur is very unusual. So if it goes below 115 degrees Celsius, so it start melts into yellow color, and the it goes above 445 degrees Celsius, it start into vapor. So the viscosity behavior is very unusual of the sulfur. So we have proposed this solution of 600 degree ultra high temperature solution for this application. And we can also inform our clients to guide our clients that you can easily use this product, and you can discuss with us for the solution for this product. So this is the application for this, because this transmitter is built for 600 degrees Celsius. So that's why we have suggested this model to the customer. Now, some more applications are there. It is used in a photovoltaic solar power plant where the temperature is 580 degrees Celsius. Then it is also used in molten salt reactor system where the temperature is 600 degrees Celsius. In energy battery making, the battery making process, we can easily use this product because the temperature will be on a higher side up to 600 degrees Celsius. Now, what are the common uses across industries? So, in the sulfuric acid production, where the temperature goes from 450 to 600 degrees Celsius, so easily we can use and inform our clients for the pressure measurement solution. Then, in the making of detergent, surfactant, manufacturing, sulfonation, we can say that the temperature will be up to 500 degrees Celsius. Then sulfur compound production, hydrogen sulfide, as we discussed earlier also. So up to 500 degrees Celsius, carbon disulfide used in rayon and rubber chemicals. So the temperature is up to 600 degrees Celsius. In agriculture, where the temperature is up to 400 degrees Celsius for ammonium sulfate and phosphate fertilizers. So we can easily guide our clients for this solution. Now, some key parameters for the selection of pressure transmitters. So, I would like to suggest you guys that you should always discuss with your client that some parameters are required for a solution, right? Because we always know the pain point of the customer. We discuss his pain point, but we never be able to give the correct solution. The question is why? Because we don't take the actual details from the customer. Sometimes we only know customer needs gauge pressure transmitter. If the customer is going to use in the vacuum, because customer don't know in which type of application which product we have to use, or we have to provide solution. So some parameters are there. Measuring media. Why measuring media is required? Because it is directly connected with the wetted parts, like chlorine gas or chlorine. So in the chlorine, we cannot use SS316L because it will react. So measuring media is very important. We have to select the wetted part accordingly, and it will also guide us which type of transmitter we have to give with the wetted part or diaphragm material. Next is the measuring range. The measuring range will guide us to select the correct span. Process temperature is also plays a major part, because if the process temperature is up to 80 degrees Celsius, so we can directly use the thread mount type PT in that case. If the temperature is up to 200 degrees Celsius, we can use flange mount type direct mount PT. Then if the temperature is above 200 degrees Celsius or 300 degrees Celsius, we can use the capillary type transmitter. If the process temperature goes above 400, like 450, 600, we can use the ultra high temperature PT. So it plays a very important factor in the selection of the correct solution. Now, what affects the ambient temperature? Ambient temperature also plays an important role, because the area where we are going to install, the process temperature might be higher. So the ambient temperature will be approx 100 degrees Celsius or 90 degrees Celsius. So we can use the selection of capillary. It based on this. So we can use the capillary to mount our transmitter or display on a remote area so that it will not get affected with the ambient temperature or the process outer temperature. Now, area installation, where are we going to install the PT? It is in non-hazardous area or in hazardous area. So this also guides us to select the PT with explosion proof model or without explosion proof model. Then output and power supply. If the customer power supply ask for the AC supply, so these instrument work on the DC, right? So we can suggest him that you can use SMPS to change your AC to DC conversion. So these are the some parameters for the selection, and these are very important for a team to select the correct solution, because we don't want to create a pain to the customer once again, because he is already dealing with the problems. We have to give him the solution. The correct solution come when the information is correct. So these are some parameters which are very important, and very important for the selection of the transmitters. Now, why we are going to use our product? So it's based having high accuracy sensitivity. First of all, we have a very wide pressure range, low power consumption is there. So we are overcoming the limitations of high temperature applications. We have quick response time. Our service sales team and product team, we are a good team, which will provide pre and post sales to the client, and it is insensitive to the external interferences. So this is the reason we can use the transmitter. Now these are some glimpses from the site. Our transmitter is installed at site. So see, these are some glimpses you can see here. The direct mount type DPT is installed, and here also the PT is installed. The DPTs are installed. This is our PT. This is our DPT with capillary. You can see the capillary here. And the process, the flange is going into the process. So these are some glimpses from the site. So this is all from my side. Thanking you all for joining this session, and it would be a great pleasure to connect with you all and taking your questions and answering them. So thank you all for joining the session. It would be great to connect with you in future, and we'll meet again with a new session very soon.
Thank you so much, Riya. That was a very insightful session. And thank you everyone for joining. Before we close, let me ask you all for the queries you have, if anyone. So please take a moment to fill out the feedback form. It's right there in chat, and you will receive your participation certificate directly in your mail. And the engagement today has been successful. Thank you, everyone. So meanwhile, you will be filling feedback form. I'll be handling queries if anybody will be having some. So Chandan sir will take it over to answer the queries.
So we will answer the questions, the queries which are coming in the chat box. Uh, so we'll take up from uh, uh, so Karan has asked what accuracy levels are available for RP 1000 series transmitter. So as discussed in the previous slides, that we have options from 0.035% and 0.06% and 0.1%. Depending upon the applications, we can select the accuracy of the instrument. And the highest we can give 0.035%. So how does a Rocksensor ensure safe measurement without cooling or heat tracing? Uh, so this is very good question. So as discussed by Riya ma'am, that we can directly use a remote capillary type pressure transmitter, which can be directly installed in the process, and we can directly measure the pressure. So how it can also reduce choking for some applications and save from choking of this application. Yes. Yes. And we can measure up to 600 degrees Celsius. Like we have discussed that in some applications like sulfur, it can solidify at a lower temperature of approximately 250 to 300, 250 degrees Celsius or below that, it can solidify. So we can directly measure using ultra high temperature pressure transmitter in that case. Just asked what is the normal response time in case of remote cell transmitters. So in generally it is 100 milliseconds, but in case of remote cell transmitter, it is 200 milliseconds. Yes. Shri Shell Katimani has asked, so do you have any other principle to measure the pressure apart from the resistance based? We have only, thank you for the question, Katimani ji. So we have a technology of monocrystalline piezoresistive sensor. So we have that technology because it's very accurate and having good response time. Basically, it's a single structure silicon sensor. So that's because of which the accuracy is very high and response time is also good. And we have a stability of 0.15% for 10 years. What are the typical temperature range? Shani has asked, what are the typical temperature ranges in sulfuric acid production processes? So if you talk about the molten sulfur, it can goes from 250 degrees Celsius up to 350 degrees Celsius in case of molten sulfurs. And in case of vapor sulfurs, it can go up to 500 degrees Celsius, 500 to 550 degrees Celsius. So in that case, our ultra high temperature pressure transmitter is very useful because we can measure pressure directly by installing on the process. So Kajal has also asked the same question. So I think I have already answered it. So Abhay has asked, could you please explain why the response time of a pressure transmitter is critical in high temperature chemical processes? So situation changes drastically in chemical processes, and it can lead to catastrophic effects. So that's why it is very important to measure the chemical process pressure in chemical processes with high response time. So our pressure transmitter, remote cell pressure transmitters can provide that with the high response time of pressure transmitter output. Uh, but how? By using the our remote cell pressure transmitter, it can reduce the drift effect because all the assembly are in manufactured in-house and provides accurate output.
For the queries right now, and I also encourage if anybody will have queries, they can ask in the chat box or directly through the audio.
So Mr. Sajuddin Ahmed asked any vibration effect. Uh, it's negligible. It's negligible in our case, and yeah, there will be very minute vibration effects. So it is negligible. Srishal Kattimani has asked, what is the isolation chamber MOC? Is it also same as the other weighted parts? So isolation chamber MOC would be SS316. It would be SS316, but the diaphragm part can be customizable as per the application requirement. So Gagan has asked, what could be the operational risk of not using a gold-plated diaphragm in hydrogen-rich applications? So you can use non-gold-plated diaphragm in hydrogen-rich application, but it won't be sustained for longer period of time, and it will cause a hydrogen embrittlement to the diaphragm.
So thank you so much, everyone. I hope we have handled all your queries. And if some queries are left, so you can mail us. We'll be happy to connect. And thank you so much. We'll be connecting again with some another insightful topic. Thank you so much, Riya. Thank you so much, Chandan sir. Thank you, everyone.
Thank you.